Couple problems from 10.2, page 564, dealing with x and y intercepts. So x and y intercepts are where an equation or a graph of an equation or a function either crosses the x-axis, those are the x-intercepts, or it crosses the y-axis, right? Y-axis, x-axis. That's an x-intercept, that's a y-intercept. Right? Y-intercept crosses the y-axis, x-intercept touches or crosses the x-intercept. So that's what we're looking for. So realize that every point along the x-axis, every point, all the infinite number of points that sit on that x-axis have a y-coordinate of 0. Right? Every point on the x-axis has a y-coordinate of 0. And vice versa, every point on the y-axis has an x value of 0. So that's how we're going to find the x and y intercepts. If you're given the graph of a function, well, it's pretty easy to find the x and y intercepts. There's an x-intercept, there's an x-intercept, there's a y-intercept. Right? You can see it. But sometimes you're not given the graph, you're just given the equations, or the functions, and you're asked to find the x and y intercepts. So to do that, we use what we just said. We're going to let, for the x-intercept, so for this equation here, which again, remember we can always call this f of x if we're calling it a function. Y and f of x, remember, same idea. So to find the x-intercept, we're going to set y equal to 0. Okay? So we just set y equal to 0 and solve for x. And that's going to give us the x-coordinate of the x-intercept. Right? So we know how to solve an equation, right? We isolate the term with the variable in it. So let's subtract 1 from both sides. Or we can add x over 2 to both sides. Doesn't matter. Let's just subtract 1 from this side. And if we subtract 1 from this side, we get negative x over 2. And we want the x by itself. So we're going to multiply both sides of the equation now by 2. You can think of it as 2 over 1 if you'd like to make it a fraction. We're going to multiply both sides by 2. 2 times negative 1 is negative 2. These 2's, 2 over 2 is just 1, so we're left with negative x. But we don't want negative x, we want x. So we just multiply both sides by negative 1, and we get the x value of the x-intercept. So our x-intercept is going to be the point 2, 0. Right? An x-intercept is a point, not just an x value and a y value, a coordinated pair, right? A pair of coordinates. So that's the x-intercept for this equation. Now, if we want the y-intercept, all we do is set x equal to 0. Right, let's separate these. For the y-intercept, we're going to set x equal to 0. Using this equation, now we get y equals 0 plus 1. Well, that's pretty easy. We get y equals 1, so our y-intercept is the point 0, 1. Is our y-intercept. And if we graph those points, connect them with a straight line, we will get this equation as a line. That's not the question here. We just want the x and y intercepts. Well, I guess we can draw a quick little picture here. If we graph those 2 points, 0, 1, so 0, 1, and 2, 0, so 1, 2, we get a line going through those points. Not a very straight line, but there it is. 0, 1, and 2, 0. And that's what the graph of that line, you can check that, put that in your calculator, and you'll see that this somewhat represents that straight line. All right, and then we got this other one, just another example, same question. So this time, And we have another linear equation. We know because x and y don't have any exponents other than 1, right? We don't see the 1. So we know this is also a straight line. If we find the x-intercept, we set y equal to 0, and we get 5x minus 0 equals 10. Again, nice, easy, one variable equation. We know 5x equals 10 when x equals 2. So amazingly, our x-intercept is the same as the previous x-intercept. Obviously, that's not always going to be the x-intercept, but in these cases, it turns out it was. The y-intercept, we set x equal to 0. So now we get 0 minus 2y equals 10. We divide by negative 2 to get our y, so we end up with a y of negative 5, which means 0, negative 5 is on the graph. So again, if we were to graph that, 2, 0, 1, 2, 0, negative 5, 1, 2, 3, 4, 5, straight line through those 2 points, 2, 0, 0, negative 5 would be what that graph looks like. If you solve this for y and put it into your calculator, you would get a line going through those 2 points looking like that. All right, so that's how we find x and y intercepts.